Hi everyone, welcome to 253 Process Troubleshooting. Today we're on the second part of Chapter 6, which is absorption and stripping. We're going to talk about the process operation. So if you look at your page 6-23, figure 6.1 is the schematic, looks similar to this. I also have a really good color-coded one that showed the flows in the last lecture. We're going to talk about the control theory, the equipment list, instrument list, the normal absorption and stripping process variables and how those process variables may affect any changes in them may affect downstream equipment. Now, the factors that affect absorption and stripping, specifically absorption, are temperature, pressure, and flow. We also found that temperature, pressure, and flow plus the level in the stripper column will be the variables to control and that will have some effect on downstream of getting the vapor catalyst out. So let's first start with the absorption column, D3. The control theory around the vapor flow. Okay, the catalyst and the off-gas vapors from the reactor 1 will now enter the absorber column, D3, at the bottom. If you look at your schematic, you'll see they come in there. The vapor flows up the column where the catalyst is absorbed into the lean absorbent. Okay, the lean absorbent flow theory. The lean absorbent is controlled at 18,000 pounds per hour by FIC 51, and that is fed at the top of the column. And this stream comes from the decanter. The liquid flows at the column bottom, absorbing catalyst vapor and becoming rich absorbent. So you have the lean absorbent comes down and then the vapors go up. And then all of the catalyst vapors get picked up because they're soluble in this particular lean absorbent. Okay, let's talk about the rich absorbent flow. The rich absorbent exits D3, the absorber column, on the level controlled by LIC 55. It likes to maintain a level of 50%. The normal rich absorbent flow rate is indicated by FI 57 and is generally 20,571 pounds per hour. So that's being pumped out by P7. Okay, the theory on pressure control in the absorption column. Now, the absorber column pressure is maintained at 80 psig by PIC 54. It restricts the flow of the waste vapors out of the top of the column. Now, assumption, if PIC 54 output increases, we're going to assume that excess is catalyst being released, not more of waste vapor. Okay, so that's just important to know. The waste vapors then are vented to the incinerator. Let's talk about the temperature control theory. The absorber column D3 temperature is maintained at 60 degrees Fahrenheit, and they do this by chilling the lean absorbent in E6. So if you see that is before it comes into the column. So chilled water is supplied by a unit refrigeration system. These conditions, along with adequate adsorbent, promote the absorption process. And I think we remember talking about higher temperature will cause the vapor then the vapor catalyst to possibly become more gaseous and then exit through the vent gas, the waste gas stream, which we don't want. So if we keep it cool, it absorbs into the liquid better. Let's talk about the control theory on the rich absorbent flow. The rich absorbent exits the column D3, the absorber, and it passes through a rich absorbent catalyst vapor heat exchanger, E7. That it is preheated by hot vapors leaving the stripping column. Okay. The preheated rich absorbent enters the top of the stripping column, D2. Okay. The steam is sparged, okay, at the bottom of the stripping column, and then that strips the catalyst vapor from the rich absorbent stream. Okay. It's important to remember that flow. So the catalyst then exits D2 at the top, and that flows into S3, which is the separator. So you'll see that on your screen, on your figure 6.1. It is separated there, and then whatever is separated, its recycled catalyst goes back to the reactor. Okay, that comes off the top, and then there's a liquid stream comes off the bottom through P8. The lean absorbent control flow, the flow control theory. Okay, the lean, which is stripped absorbent, collects at the bottom of the stripping column, D2, and it's pumped out by LIC 56, pumped out by level control. That level's at 50%. The lean absorbent is split after LY 56 into two streams and is joined by an absorbent makeup from the decanter. There's a blow down stream FIC50 and the lean absorbent stream FIC51 with the makeup stream FI58. Okay, look at your schematics to understand that. Remember that lean absorbent means your catalyst has been removed, stripped. Okay? All right, blow down, flow. The stripper column D2 blowdown is controlled at 500 pounds per hour by FIC50 and it is sent back to the decanter. The blowdown removes the condensate created by the steam condensing in D2. Now the makeup flow. So the majority of the D2 bottoms with absorbent liquid makeup is measured by FI51. Makeup is added through FY51 to maintain a total flow of the lean absorbent without the catalyst at 18,000 pounds per hour. This liquid is chilled in E6 and it flows back to the absorber column as lean absorbent. Okay, steam flow. So the heat in the stripper column, D2, is provided by a 10 psig steam from the steam generation process. There's a makeup steam supplied at 200 pounds of psig source as is needed. A split range controller, FIC52, opens from 0 to 50% for full valve position on the 10 psig steam. From 50 to 100% output, FIC52 controls the 200 pound makeup steam, and the normal steam flow rate is 4,000 pounds per hour. Temperature on our stripping column. At normal rates, the temperature of the absorbent in the lower section of the stripping column is 105 Fahrenheit as indicated by TI59. It is not a controller, it is only an indicator. The elevated temperature and the vacuum, PIC53, it runs at 42 millimeters of mercury, provided by the steam jet downstream of the liquid vapor separator, promotes the stripping of the catalyst vapor from the absorbent liquid. Okay. Catalyst flow. The catalyst vapor from the stripping column D2 is cooled in the rich absorbent catalyst vapor heat exchanger E7, and that flows into the liquid vapor separator S3. Right? The catalyst vapor flows from the liquid vapor separator S3 back to the reactor. Okay, so it completes its cycle after it's gotten after it has been absorbed and then stripped. Okay. Now this is important to understand, so just pay attention to this part about the pressure vacuum on the separator system. The catalyst vapors are pulled from S3 by a vacuum jet, and that is being controlled by PIC53. There's a bypass of PIC53 which maintains the vacuum in S3 at 42 millimeters of mercury. D2 is also under vacuum by the same PIC53. Okay, so D2, the stripper, is also under a vacuum. Liquid flow now for the separator. The liquid from the liquid vapor separator, S3, that flows on a level control by LIC61 through a seal leg back to the decanter from the bottom of S3 via pump P8. The normal liquid flow rate is 4,000 pounds per hour as indicated by FI60. Okay, now we're just going to kind of talk about the absorption and stripping equipment list just very briefly. Okay, that's on page 625, and we've talked about this from our schematic. So you have D2 is your stripper column, D3 is your absorber, E6 is a lean absorbent chiller, one heat exchanger, E7 is a rich absorbent catalyst vapor heat exchanger. P6, 7, and 8 are also pumps, and they're correlating to each equipment piece. And S3 is your liquid gas separator. So page 6-27 is all of the list of your instrumentation. Okay, you can look at that in your book. All right, now let's talk about the normal operating conditions. So we're going to look again at another page, and they'll indicate all of these areas, which we have been doing in pretty much the whole chapter, right? So page 629 gives you the normal operating conditions. We talked a little bit about these in the control theory. Some of these numbers were given different ranges. Okay, so you see here that these are all listed. Now they're not described again, and so you go to the instrument list as well. Okay, now we need to talk a little bit about the material balances just so that we get that straight. We're going to look at an overall material balance, then we're going to look at an absorber column material balance and a stripper column. So these will help us in our troubleshooting problems. Okay, Now I want to just show you, I'm going to give you only block diagrams, all right? So what this is here is just, I took the system and I don't have the arrows going back and forth because I just want to show you the inputs and the outputs. So in the whole system, the stripper, absorber, and the separator, okay? So this is the overall material balance. All right, so number one, the reactor gases come into D3, the absorber. They are not metered, so you're not measuring them. 2, the Fi58, which is your makeup absorbent, enters in the absorber. Now this enters down here, but it's not, I'm not really worried about showing that. I'm just giving you the ins and the outs. And then this makeup comes in at the top. So the gas comes at the bottom and this comes up at the top, regardless of all of that. Also in D2, you have steam coming in. Also that comes in at the bottom, right? Because this absorbent comes around and swings up to the top. All right, but right now I'm just showing you the ins. Okay, number 4 is your vapor catalyst to R1 is not metered. All right, that's what goes back to the reactor after it's collected. And number 6 is your FIC50 blow down to decanter. I think I've numbered these incorrectly. Sorry about that. And then number 7 is your FI60 condensate to decanter. So we're going to look at the overall on the next screen. See, I said 4, 5, and 6. I messed that up. Sorry. This should have been 5 and this should be 6. Okay. Now, 1. Your vapor from the reactor is not metered. Your absorbent makeup, Fi58, okay, is at 500 pounds per hour. Your steam comes in at 4,000 pounds per hour. Now remember, this is the overall, all right, not to each individual column. Your output is your waste gas, and that is not metered. We also have the catalyst, which we have to calculate, and we'll show you that on the next screen. Your stripper blowdown is at 500 pounds per hour, and your condensate is 4,000 pounds per hour. So these kind of balance here, don't they? Overall, you'll see. So the vapor in and the waste gas out are basically probably equal. All right, now I want to talk about the absorber column. We're going to look at this material balance, all right? So the absorber alone has the reactor gas coming in at the bottom, and the lean absorbent flow comes in at the top. Remember, it's lean because it has not yet captured any of the vapor catalyst that's coming over here. What comes out will be the rich absorbent stream to the stripper, okay, because it has absorbed now the catalyst, and the waste gas to the incinerator. That is not metered. So our balance is Fi57, okay, over here, what's coming out, minus Fi51, the lean in. So you have your rich out minus your lean in. When you subtract the difference of those two, okay, you'll get your absorbed vapor catalyst, okay? So let me explain to you here. The two gas streams are irrelevant for this particular mass balance because what we're interested in right now is how much catalyst is being absorbed in from the lean absorbent, is absorbed into the lean absorbent, now becoming the rich absorbent stream. Okay, so let's look at that. So the vapor from the reactor is not metered. The lean absorbent is 18,000 pounds per hour. The rich absorbent is 20,571, and the waste gas to the incinerator is not metered. So what we're interested in is this. The total amount out minus the lean means that difference is what was captured in the lean absorbent, now becoming the rich absorbent. So 2,571 pounds per hour is what's the catalyst. Let's look at the stripper balance. Now the stream coming in is the rich absorbent. Okay, so we want to take out the vapor in this particular. We want to take out the vapor catalyst in here. And then the steam comes in at the bottom. Okay, so what comes out the top then would be the FIC lean absorbent comes out from out the stream to the absorber D3 back around. The vapor catalyst with the steam to S3 is not metered, and that is what's going to S3. Okay, so now we look at the rich absorbent and the steam. They both come in, and the lean absorbent and the catalyst and steam. So this equation is Fi57, okay, plus FIC52 equals this one minus that. That's how we can calculate this one, okay? So we get the numbers here. Okay, we also need to look at the ratio of steam to catalyst, and that's just about a 1.56 to 1 ratio. Steam coming into the catalyst vapor, okay? So go to self-study questions on page 631. It's important to know all of those mass balances to answer the questions. So just let me know if you need any help and we'll go over them. Okay? On to the next PowerPoint after this. Have a good one. I'll talk to you soon.